This is part 2 of the lesson on empirical and molecular formulas. In part 1, we looked at how we could determine the empirical formula of a compound from percentage composition or experimentally determined mass data. In this part, we're going to look at how we can then determine what the molecular formula is of a compound. So recall that a molecular formula tells you the exact number of atoms in one molecule or formula unit of a compound, whereas an empirical formula gives the lowest whole number ratio of atoms in a compound. What this means is that the empirical formula can be multiplied by a whole number to get the molecular formula. So the example from part 1 was that the empirical formula for benzene is CH, and that the molecular formula is C6H6, which means if we multiply the empirical formula by 6, we get the molecular formula. So in order to convert from an empirical formula to a molecular formula, we need to find that whole number. And we can do that using molar masses, because the molar mass of the molecular formula is also the same whole number multiple of the molar mass of the empirical formula. So let's look at an example to see what that means. So the empirical formula of a compound is CH2O, and the molar mass of that compound is 90.1 grams per mole. So what is the molecular formula of the compound? So to go from empirical formula to molecular formula, we first need to determine the molar mass of the empirical formula, so the CH2O. So we do that by adding the molar mass of carbon to 2 times the molar mass of hydrogen plus the molar mass of oxygen, and we get that the molar mass of the empirical formula is 30.03 grams per mole. Now we want to find out what that whole number multiple is, so we're going to divide the molar mass of the compound by the molar mass of the empirical formula. So we have 90.1 grams per mole divided by 30.03 grams per mole, and that gives us an answer of 3. When you do that division, your answer should be very close to a whole number. If it isn't, you have made a mistake. In this case, you can't get 1.5 or 1.66 or anything like that. It needs to be close to a whole number. And if it isn't, go back and check your work. So the whole number multiple in this case is 3. So we can now determine what the molecular formula is by multiplying the empirical formula by 3. So 3 times CH2O gives us C3H6O3. So that's our molecular formula. So we'll look at another example, and in this one, you're not given the empirical formula, you're given the percentage composition. So determine the molecular formula of a compound containing 85.7% carbon and 14.3% hydrogen. You're also told that the molar mass of the compound is 84.0 grams per mole. So the first thing we're going to need to do is calculate the empirical formula using the method from the first part of the lesson. So we're going to take those percent composition values, we're going to assume that we have 100 grams, and we're going to convert them into masses. So we have a mass of 85.7 grams of carbon and 14.3 grams of hydrogen. Next step, you'll remember, is to convert to moles, right, using the molar mass of the element. So we take the 85.7 grams of carbon, divide it by 12.01, and we get 7.13572 moles of carbon. We do the same for hydrogen, 14.3 grams of hydrogen divided by 1.01 grams, and we have 14.15842 moles of hydrogen. We're then going to divide by the smallest. So for carbon, that is the smallest, so we get 1, and then for hydrogen, we get 1.984, which is very close to 2. So from this information, we now know that the empirical formula is CH2. Now that we have the empirical formula, we can determine the molecular formula using molar masses. So we're going to find the molar mass of the empirical formula, and it happens to be 14.03 grams per mole, 1 carbon and 2 hydrogens. Then we're going to take the molar mass of the compound, which was given in the question, and divide it by the molar mass of the empirical formula. So it's 84.0 grams per mole divided by 14.03 grams per mole, and we get 6. Now we can write the molecular formula by taking that 6 and multiplying the subscripts in the empirical formula. So 6 times CH2 is going to give us C6H12. And so that's the molecular formula. So now you've learned the methods to determine both the empirical formula and the molecular formula for a compound when you have information such as the percentage composition, experimental mass data, and the molar mass.